Welcome. In this video I'm going to show you how you can determine epsilon square using JupyterLab and Python 3. So unfortunately for the Kruskal-Wallis test there is not a single agreed upon effect size, but epsilon square seems to be a good choice. And an epsilon square of 0 would mean that there's no differences between the categories, while 1 would indicate a full dependency. Now there's no formal way of determining if 0.4, for example, would be high or low, and I've not been able to actually find any rules of thumb for the interpretation on this. So what I've done is I since this is a square variable, so it's epsilon squared, I took a look at the rules of thumb for a correlation coefficient and simply squared the thresholds, and that gave rise to this little table here. Now, by no means I know if this is any good or not, so don't pin me down on this. If you do have a reliable source for good rules of thumb, let me know in the comments below. So just to find how to create this epsilon square, I'll be using an example which I'll load as a pandas data frame. So I'll first import pandas. If you've never installed pandas before, use an exclamation sign and then pip install pandas. Then I can use read CSV, so to load a data file, and with head I can show the header, which are the first 5 records. Now for this example I need a nominal field, which is going to be location, that contains my categories, and an ordinal field, in this case teach motivate, which was the motivational qualities of the teacher. And I'm gonna store those as 2 separate variables so I can use them later. Now let's have a quick look at the results, and this is the cross table, and I can see that 10 students said fully disagree in Haarlem, for example. These are not in the correct order, but that's not so important. More annoyingly is that these are text and I need these to be numbers. So I'll have a quick look at those ordinal unique scores, which are fully disagree, and there's even a none, which are missing values. So I need to assign these to a number, and I'm going to use 1 to 5 for fully disagree to fully agree, and this is known as a Python's dictionary. I'm going to call that my coding. Then I can use that coding to replace the values in the motivation, and I'm going to call that motivate recorded, so that I have a new field, teach motivate recorded, which now should have only numbers in them. So let's have a look there, and indeed there are only numbers now. Again, these are not in the correct order, but that doesn't matter. You can do a sort and it will be in the correct order. I'm not aware of any packages that can actually calculate epsilon square, so if you do know any, let me know in the comments below. But the formula is pretty straightforward once you have the Kruskal-Wallis H value. It's then simply the number of scores plus 1 divided by the number of items or scores squared minus 1. Now in the other video I've shown how you can calculate Kruskal-Wallis H. I'm not going to repeat that here. I'll use the Pingouin package for that, and it will give me the Kruskal-Wallis test results. And one of those is actually the H value, and I simply want it as a value, which is in this case 21.33. Then I need the sum, so the total number of counts. I can use that cross table. I need to sum twice. The first one is, I think, adding up the rows, and then do that again so that it sums up the row totals, and then you have the grand total. Then I can complete the formula simply by filling it out. I have the H value, I have the number of scores, so I'll simply fill out the formula and I get an epsilon square of 0.40. As can be seen in the table from the introduction, it would fit into the categories strong. I can also use some if and else statements, if you like, simply to go over the table, and that should give me the same result as strong. And that's all there was to it. I hope this video was helpful, and thank you for watching.